Welcome to the podcast, Matei.
Thanks a lot. Excited to be here.
Can you start by telling us a little bit about the origins of Databricks and how it led you to where you are today?
Sure. Yeah. So Databricks started, from a group of 7 researchers at UC Berkeley back in 2013, and we were really excited about democratizing basically the use of large data sets and of machine learning. So we had seen, the web companies at the time were very successful with these things, but most other companies, most other organizations, things like scientific labs and so on, weren't, and we were really excited to look at making it easier to do computation on large amounts of data and also to do machine learning at scale with the latest algorithms. So we had started, during our research, we worked with some of the web companies. We also started open source projects, like most notably Apache Spark, which, was essentially, the first version of it was my PhD thesis. And we had seen a lot of interest in these. And we thought, it would be great to start a company to really reach enterprises and make this type of thing much better and actually allow other companies to use this stuff.
Can you just give us a sense of what Databricks looks like today from like a scale and product suite perspective?
Sure. Yeah. So Databricks offers a pretty, comprehensive data and ML platform in the cloud. It runs on top of the 3 major cloud providers, Amazon, Microsoft, and Google. And it includes support for, data engineering, data warehousing, machine learning, and most interestingly, all this is integrated into one product. So, for example, you can have one definition of your business metric that you use in your BI dashboards, and the same exact definition is used as a feature in machine learning. And you don't have this drift or copying data, and you can just kind of go back and forth between these worlds. The company has about 6,000 employees now, and last year we said that we crossed $1 billion in ARR, and we're continuing to go. It's a consumption-based cloud model where customers that are successful can go over time and bring in new use cases and so on.
Did you think the opportunity was as big as it has been when you started the company?
Yeah, we did. Well, we definitely didn't, anticipate necessarily to go to this size, right? A lot of things can go wrong, but we were excited about the confluence of a few trends. So first of all, it's so easy to collect large amounts of data, and people are doing it automatically in many industries. And second, cloud computing makes it possible to scale up very quickly, do experiments, scale down, and so on, which enables more companies to work with this kind of thing. And then the third one was machine learning. So we thought, these are powerful trends. And the exciting thing for, us as a company is we didn't invent cloud computing. We didn't necessarily invent big data or anything, but we were able to start at a point in time when many companies were thinking to move into this space and just provide a great platform for that. And there's this migration already happening. And, if you provide the best platform as people are migrating to the cloud, they'll consider it.
You still keep roots in research. You have a research group at Stanford. Can you talk about that?
Yeah. So I'm a computer science professor there, so I split my time between that and Databricks. And we work on a bunch of things. We, usually like looking farther ahead into the future. And we've worked a lot on scalable systems for machine learning, how to do efficient training on lots of GPUs and stuff like that, or how to do efficient serving. And then another thing I'm really excited about that we started about 3 years ago is looking at knowledge-intensive applications where you combine a language model with something like a search engine or an API you call or something like that, and you try to produce a correct result, maybe for a complicated task, like do a literature survey and then like tell me, what you found about this thing with a bunch of references or counter arguments or whatever. And I have a great group of PhD students that are working on that and, exploring different ways to do it.
How did Databricks decide to start working on Dolly? Like what sparked that, and how did you first get going on that?
Yeah, so we'd had customers working with large language models of various forms, even before ChatGPT came out, and but they were doing the more standard things like translation or sentiment analysis or things like that. A lot of them were tuning models for their specific domains. I think we had almost 1,000 customers that were using these in some form. But then when ChatGPT came out in November, it got people interested in using these for a lot more than just analyzing a bit of data, and instead creating entire new interfaces or new types of computer applications, new experiences in them. And so there was intense interest in this, even at a time when, the industry in general is being conscious about spending and which things are really required and so on. This was an exciting one. And the really exciting thing about ChatGPT, as you both know, is the instruction following, or basically the ability of it to kind of carry on a conversation and listen to the things you're telling it to do and do those, as opposed to just completing text or just telling you a small amount of information, like this is a positive or negative sentiment. So we really wanted to see whether it's possible to democratize this and to let people build their own models, with their own data, without sending it to some centralized provider that's trying to sort of learn from everyone's data and, kind of control their destiny in this space. We were exploring different ways of doing it. And in particular, Dolly is partly based on this great result from some other faculty members at Stanford called Alpaca, where they tested a way to, basically they used the model to generate a bunch of realistic conversations, and then they use this to train another model that can now carry on conversation on its own. And so we tried essentially cloning that approach, but starting with an open source model, and it actually worked pretty well. And so that's what became Dolly. But yeah, we've been looking at the space for a while and seen incredible demand for these kinds of applications.
Yeah, I think the industry has really been very focused on scaling data, parameter size, and flops. And I think you all really have showcased the power of instruction following, even at something that's relatively smaller scale. Could you explain that and how that all works?
It's very interesting, and I think there's actually a lot of research still to be done here, because these models have been mostly locked up in these very large companies for a while, and everyone thought it's too hard to reproduce them. So the interesting thing is language models had existed for a while. You basically trained them to complete words. Here's a missing word in the text, can you fill it in? And then at the beginning, when people tried to apply them to real applications, not just, I erased a word on my homework, fill it back in, but actual applications, they had always done various ways of training something else on top of, say the feature representation in these. And so there was a lot of domain specific work, but you could build a sentiment classifier or stuff like that. Is it positive or negative? Probably 3 years ago now. OpenAI published the GPT-3 paper, which is called Language Models Are Few-Shot Learners. And they said, number one, we trained a language model on 170 to 175 billion parameters, and we trained it on, I think it's 45 terabytes of text. So lots of data, lots of parameters, and it's pretty good at language modeling. And then number two, they said you can actually kind of prompt this with a few examples of a task, and it picks up on the task and does it. So lots of people were working on that. How do you prompt it? What's the best example to show? But everyone assumed that for that capability, you need a giant model to begin with. So even the researchers in academia were calling into GPT-3 and trying to build stuff based on it and study this phenomenon. And then last year, 2022, OpenAI published this other paper, which was sort of instruction tuning these models, where they said, hey, we used some human feedback and then some reinforcement learning, and we got this GPT-3 model to actually just listen to one instruction. It doesn't need a complicated prompt with lots of examples, and it kind of works. And then they released a version of this as ChatGPT. So I think in a lot of people's minds, the scientific view of it was, first you need a giant model, and then you need this reinforcement learning thing, and only then do you get this conversational capability and broad world knowledge. So it's actually very surprising. In Alpaca, we just had a larger data set of human-like conversations. And we had this, very kind of modest size open source model that's only 6 billion parameters, only trained on less than 1 terabyte of text, so like 50 times less data than GPT-3, and it still has this behavior. I think it's been pretty surprising to a lot of researchers, the size of model that still gets you this kind of instruction following ability. So I think this kind of an open research problem, like what exactly about these data sets is it that makes them good at this? What are the limitations? Are there tasks that these are clearly worse at or better at? It's actually kind of hard to evaluate with long answers because it's hard to like automatically score them and say, this is a good Seinfeld skit that you generated and this is like a bad, Barack Obama speech. So, but I think we'll figure this out. Yeah.
Were there any things that emerged from the model that you also found surprising? Like you mentioned one aspect of it just in terms of the approach you took, and with dramatically more limited data and approach, you ended up with really performant behavior. Were there other things that were unexpected properties of what you did with Dolly?
Yeah, I think to me the most interesting thing is it's surprisingly good at just free-form, like kind of fluent text generation. So you can tell it to like create a story or create a tweet or create a scientific paper abstract, and it does a pretty good job at that. And before that, whenever I talked to my NLP like researcher friends, they thought that creativity was the thing that required a lot of parameters from something like GPT-3. Like they actually told me, the knowledge intensive stuff, like remembering facts, tell me the capital of like France and whatever. That's not surprising that a small model with a few parameters can do it, but the creativity, that's like really hard. So this one is actually pretty good at the creativity and generation. It's less good at remembering lots of facts, which kind of makes sense given the parameters. So if you ask it about common topics, it'll be good. If you ask it like the author of a book, it might give the wrong one. I think we had an example because we've actually been building a slightly bigger version of this too. And we had this question with like, who is the author of Snow Crash, which is Neil Stephenson. And the initial Dolly model said Neil Gaiman. So, it's still a Neil, it's still an author, but it's still
sci-fi, yeah.
Yeah, it's still kind of, So it's less good at remembering facts, but pretty good at coherent sort of generation.
Yeah, the name Dolly basically references the first cloned mammal, Dolly the sheep. Can you explain the reference within the AI space?
Yeah, so it's based on, cloning this other model from Stanford called Alpaca, but doing it with an open data set. So, and that itself was based on something that Meta released, I think maybe 3 weeks ago or less, called Llama, which is, they took a modest size model, 7 billion parameters, and they trained it on a ton of data. I think they said 1.4 trillion tokens or something like that, which is, I don't know how many bytes of data it was, but it was multiple terabytes of data, basically. And they said, hey, by just training this for longer, we got a small model that's actually producing pretty high quality content for its size. So there were all these kind of woolly sort of animals out there, and we thought it's just too perfect to like clone it. And there are all these other things like, it's like the Dolly llama. I don't know. There are all these
that's
like
a great name.
things.
That's a good name.
Yeah. So,
and then are there other things that you can share that you all have coming in the background at Databricks or at your Stanford Lab in terms of this more general area of language models?
Yeah, I mean, at Databricks, definitely, we're using everything we learned from Dolly, and we're learning from our customers to just offer a great suite of tools for training and operating LLM applications. We already have a popular MLOps platform, and we also have this open source project called MLflow that integrates with a lot of tools out there that our offering is built around. So you can expect some nice integrations into that. Separately, we're also working on Databricks product features that use language models internally, and learning a lot from developing those and feeding that into our product. So I think in the next few months you can expect it. And we also have this big user conference, Data AI Summit, coming up in June that will probably have a lot of stuff about this. And I would say as a researcher and also kind of with my Databricks hat on, the thing I'm most excited about is really connecting these models with reliable data sources and making them really produce reliable results. Because if you use ChatGPT, or GPT-4, the two big problems with it are, number one, like the knowledge is not up to date. It only knows stuff it was trained on. And number two, a lot of the things it says are inaccurate, and it's confident but like wrong in various ways. And I think you can tackle both of these by combining some kind of language model with a system that pulls out like vetted data, either from documents like a search engine, or from APIs and tables and stuff like that inside your company. Like, for example, when I talk to the chatbot in my bank, it should know my latest bank account balance and transactions and stuff. If I'm like, can you cancel the payment I made because I unsubscribed? You should just know what that means. So cracking how exactly to do that isn't easy. It may actually be easier with small models than with big ones to reduce hallucination from them. But I think it's still an open question. But I think if we can figure this out, then these become a much more reliable component in an application.
Maybe we'll go from there to just like projecting a little bit about like architecture and research. So much of the industry is focused on model scaling, right? Improving reasoning that way. Like, how much do you think that matters in terms of, I guess, like real world usage in production with your customers in the near term?
Yeah, great question. So to me, at least, the relationship between scale of the model versus quality of the data and supervision you put in versus like design of an application around it, and those things, and like overall quality, I think the relationship is not 100% clear yet. Like, to get a really reliable model that, say, I don't know, can like make a pharmacy prescription or something like that, maybe you need a trillion parameters. Maybe you actually need a really carefully designed data set and like supervision process, which is kind of traditional sort of ML engineering type work. Or maybe you actually need a clever application where like you're chaining together a couple of models and things, and you're saying, well, does this make sense? Can I find a reference? Can I show this example to a human if it's really hard? So I think it's a little bit open. The thing I can say for sure, especially and Dolly and like other results like this really highlighted, is it does seem that the core tech is getting commoditized very quickly. So if you just want to run something like today's ChatGPT, it will be a lot cheaper because all these hardware manufacturers are building devices that are specialized and much cheaper. And another thing that's making it less expensive is we're figuring out ways to get a smaller model with less data, fewer parameters and stuff to get similar performance. So that, I think, is happening faster than at least I would have thought, a few months ago. So at least to get something with today's capabilities, I think it'll be very affordable, and you might just be able to run it locally on, your phone or something. The question of how large can, if you make a much larger model, is it going to be a lot smarter? I think it's still a bit unknown. I mean, there are people who argue it's going to be very good at reasoning, but at the same time, this kind of token by token generation we're doing now is not an amazing format for reasoning, because you have to like linearly like say one thing at a time. So it's not really good for like making plans or comparing versions. I think to get a really smart application, you'll need to combine today's language modeling with some other sort of framework around it that uses it multiple times or explores a plan space or whatever, and then you might get something good. And it's also possible that the very largest models are simply memorizing more stuff. So like they're impressive in terms of trivia. Like I can ask it about some random topic and it will know, but they're not really like smarter at solving even a basic, word problem. So yeah, I'm not sure. Unfortunately, especially with training from the web, it's often very hard to tell apart like reasoning from memorization. Essentially, did it see that thing before? So it's I think actually being able to do experiments where you train these on carefully selected data and it will lead to better understanding of like what they can do.
Yeah, that makes sense. Maybe if we think a little bit, just because you have great visibility from your role at Databricks, like what other tooling do companies need, like your enterprise customers or just generally enterprises need to make use of these models? Because you said, we believe the core technology, the models themselves are getting commoditized.
Yeah. So I think definitely the first piece is you need a data platform that can actually build, reliable data, right? So we think that's like the, the bread and potatoes of like getting anything. You need some, a basis to like sort of build on. So we think that will become really important. And, maybe data platforms will have to evolve a little bit to be better at supporting unstructured data like text and images and so on, and to do quality assessment and stuff like that for it. That's one piece. I think another piece you need the ML ops piece of like being able to experiment with things, deploy them, A/B test them, and so on, and see what does better and improve it incrementally. And I also think these models will need a good connection to operational systems inside the company to do really powerful things with like the latest data. So, you saw probably the support for tools in ChatGPT. Before that, there were lots of groups working on at least models integrated into search engines, sometimes into calling other tools as well, like calculators. I think it's still a little bit open-ended. There's one extreme where people say the model will figure out what tools to use on its own. I think for like enterprise use cases, that's a little bit like more than you really need. You can kind of give it some tools and feed it stuff, and it doesn't have to discover and like read the manual to figure out which one to use. But yeah, I think that's another piece you'll need for like really powerful applications. And then I do think infrastructure, like just basic training and serving infrastructure is important too when you start to care about performance, like about latency and speed. And you can see some of the new search engines using these models are not that fast, right? They're like a little bit slow. It would be nice to have it faster. And for automated analytics, it's even more important that it's efficient. So I think there'll be a lot of activity there. Yeah.
Where do you see enterprises getting the most value from investing in, I guess, more traditional ML and then like some of the language model stuff to date?
Yeah, great question. So traditional ML, we're seeing actually virtually all major enterprises, in all industries are using it. It's changed a lot in the past decade, actually. So, it's very good for forecasting things in general and for automating certain types of decisions. So, for example, optimizing your supply chain, right? You don't have time to look at like exactly everything that's going on, but and think about it and have a meeting. But if you do order like the right amount of like parts to meet your demand this week, or if you minimize the amount of time an agricultural product like sits in a warehouse and like you lose degrades in quality or stuff like that, it matters a lot, and it can have a huge impact on the profitability of a company. So we're seeing a lot of that, people applying it to automate supply chain and to automate basically their operations in various ways. And then there are more classic use cases like fraud detection and stuff like that, where also it's always an arms race, and like you're trying to do the best you can, because every % of like accuracy you do better in can translate into huge impact. With language models specifically, and especially with kind of conversational ones, the really exciting thing is interfaces to people. And I think customer support is a very obvious one. Maybe things like recommendations or asking questions on a product page, in retail, things like search augmented with stuff is one. And we've also found that just internal apps in a company that have a lot of internal data can benefit from this kind of thing. So like one of the things, we've built, for example, is inside Databricks, we have all these resources for, engineers to understand how different parts of the product work, how to operate it, like all the APIs. And, people used to just ask each other questions in these Slack channels for each team. And we could use that data, like the questions and answers plus the data, in the actual documentation to, essentially automatically answer many, many such questions and just save people a lot of time. So I do think that any app that has kind of business data or like stuff written by humans in it, like, like your issue tracker for your software development, or like your Salesforce or something like that, could benefit from, these kind of interfaces. Yeah.
Yeah, it seems like any type of forum or anything else instantly becomes like data that you can use to fine tune or train a model that's specific to your customer support use case. Or you could use an embedding or something to do interesting things with it. So it seems like there's some really cool stuff to do. Are there any specific areas that Databricks is not focused on that you think would be especially interesting for somebody to build from a tooling perspective for enterprises trying to use some of these technologies?
Yeah, I think there are a lot of these. I think it's very early on. So probably one of the most obvious ones is just the domain or vertical specific models and tools. And I actually think even a lot of the enterprises that like have a lot of the data in various domains might turn more into data or model vendors of some form in the future, as they use this to like build something that no one else can. So I wouldn't be surprised at all if you see like the next, wave of companies for say security analytics or like, biotech or analyzing financial data or stuff like that, really built around LLM technology in there. And I also think in general in the app development space, like how do you develop apps that incorporate these tools? It's very open. It's not clear what the best way to do it is, and you might end up with like really good programming tools that focus on this problem. I would say, for people thinking about startups and so on, like you want your startup to have, a long-term defensible moat, ideally something that grows over time also. So anything around the unique data set, for example, or unique like feedback interaction you have is always good, right? Like honestly, even something like adding ML features in your product that just kind of learn from your users and do better recommendation and so on could eventually become a moat where like others just can't easily catch up. But I think that anything that's around custom data sets is sort of safest.
When you were working on Spark for your PhD, did you think you'd become a founder? Was your intention to start a company, or did you just think it was interesting research to do, or both?
It really wasn't. Yeah, I mean, as a grad student, I've always been interested in just like doing things that help people, that have an impact, help people do cool things. And, I had seen these open source technologies out there for distributed data processing. I thought, okay, well, I'll try to start one and see how it goes. I wasn't sure that people would really pick it up and use it, but I wasn't looking to be a founder necessarily. I was just looking to do something useful in this like emerging space. And honestly, I thought like, hey, if I'm, I was at least considering to be a computer science professor. And I thought if I'm going to be a professor and all the most exciting computing is happening in data centers today, and like, I don't know how that works, how am I going to teach, computer science to people? So I better learn about that stuff. But it turned out to be something, more broadly interesting. Yeah.
Well, what was the most unexpected thing about being a founder?
There are a lot of challenges along the way. I think just being able to learn about all the aspects of a business and how much complexity there is in each one. Starting out as a more technical person, at first I didn't really know what to expect, but there's a ton of depth in each one. And if you understand them, if you like really try to understand them, get to know the culture of people there, like really get to know what they're thinking about, you can make much better decisions across, multiple aspects of your company.
Is there anything that you would advise people coming from a similar background to yours? I have a PhD as well, although it's in biology. And I feel like there's certain things that I learned in academia that was really valuable. And then there's a bunch of stuff I really needed to unlearn as I went into industry. Are there specific pieces of advice you'd give to technical founders or PhD founders in terms of things that they should unlearn?
Well, I think you should unlearn like a lot of research, at least in computer science, the kind of stuff that I've worked on. A lot of research is mostly prototyping. It's like, can we showcase an idea, but it's not really software engineering of like, we'll build a thing that can be maintained and like runs flawlessly in the future and like supports, problems. So I think you should kind of unlearn just the focus on short-term stuff and think about how is this going to go over time. Eventually, right? There is a phase of the company where you're just prototyping to get a good fit, but you should design things so they can evolve into something that's very reliable long-term. The other thing is, I think unlearn trying to invent everything from scratch. You should really be careful about like, hey, where am I doing something unique? Or if I'm doing something different from others, like, why is it, right? Don't do it just for kicks. So, because in research, it's very tempting to say, I did this new thing. I'm going to try all the fanciest, like, new ideas in each component of it.
Was there something that you guys like experimented with being like, first principles unique about that you then said, there are systems for this?
a good one early on was just deployment infrastructure for like how do we deploy and update our software across all the clouds and so on. And we soon realized it's better to go with really standard things like Kubernetes and tools like that than to try to do something custom, because they're evolving very quickly. So yeah, that's kind of a good example where like you at the beginning you say, how hard can it be? Let's just build something. But then you realize, wait, every month there's like new stuff coming out, and maybe this isn't where we want to focus on.
So maybe just thinking about being like CTO now of a very large company, like how is your lens as a researcher, a computer science researcher, informed your thinking as a CTO?
Yeah, I think first of all, as a researcher, like you do learn to you think a lot about the long-term trends, like what could things look like 5 or 10 years from now, or what's kind of the fundamental things here. So for example, this thing about LLMs being commoditized, and or honestly the thing about them kind of maxing out at more parameters, I think many people hadn't really thought about that. But if you think back, like there is a lot of room to improve efficiency, usually in hardware and software for an application. And this particular application is kind of simple because it is all basically like 2 or 3 different types of matrix operations. So like it's sort of the hardware designer's dream to do this stuff. And also there are usually diminishing returns from scale in terms of quality of models in general. And you can also kind of see it in other areas, like in computer vision, for example. We don't have trillion parameter models. You get actually pretty small models that you can train for a specific task that are good. In self-driving cars is another example. They rapidly improved in quality up to a point, and then they kind of plateaued, and they're still not really ready for prime time. Eventually you hit some limits.
There are plenty of people who are researchers in the field who don't really see an asymptote, right? With scaling. And so where do you believe that limit comes from? Like parameters, compute, data, something else?
I just think a lot of things like scale sublinearly in general. Now, it's hard to tell for things like reasoning and so on, but certainly in kind of classical machine learning, like for example, if you're trying to learn a function that like separates positive and negative examples, and as you add more data, like your accuracy doesn't really improve linearly. Like with a few examples, you get a pretty good estimate of that boundary, and then with more of them, it gets a little bit better, but it doesn't get like that much better. So it's just, I think it's common. That would be my main reason. Now, I think the one thing, so with language models specifically, I think the part that does go linearly with more parameters, or should, is ability to just memorize more stuff. So if you wanted to tell you like who was on the 5th episode of like Friends, and like what was the second line they said and stuff like that, like, yeah, more parameters will get you a neural network that just by putting that input, like can tell you that stuff. But that wasn't that interesting to me, because I think the right solution for that is look things up in a database, like do retrieval, right? Do a search index. I think from a computation perspective, it's very inefficient to have like 1 trillion parameters and have to actually load them all and add and multiply by them each time you make an inference, because they're just encoding knowledge, most of which you don't need for that inference. So that one I wasn't as excited about. But I think there are people who are just excited about neural networks, like how do, it's the same kind of people who wonder like how do brains work, like how do animals learn, who are just excited about, wait, I only had some neurons and I put in this stuff and it remembered it. But as an engineer, I'm not that excited, because I'm like, yeah, I could have built a database that did that. But in terms of like, hey, I just trained a network with gradient descent and it did it, that is kind of cool. Yeah.
Yeah, I feel like people are almost the opposite, where we're actually quite bad at memorization. We're very good at inferring things. And so it's interesting to ask, what is the basis for that computationally?
Yeah. The other thing that we're learning, though, from this is it does seem that the type of data you put in and the kind of fine-tuning, essentially it's like weighing the data has a lot of impact. So this instruction tuning stuff is like really, we have only a few examples of instruction following, but since we do fine-tune the model, it's as if we put a very high weight on it and had lots of examples of that in our training set. And I think it's still an open question. Like, for example, if you made a lot of examples of logical puzzles, right? Like you just generate some problems and solutions, would you get a model that's better at logical reasoning? There are other things you can do. I also think a big problem with current models, I think I hinted at this before, is we're just calling them to generate one token at a time. So, for example, you've probably seen this like chain of thought reasoning thing. Like if you ask a model a math problem and it just tries to answer like how many sheep were there, it might say like 7 or something, and then it tries to make up the explanation and it's like wrong. But if you tell it do the explanation first, think step by step, and then answer, it's more likely to be right. But you can imagine other versions of that, like if it had a scratch pad, if it had a way to backtrack to say, this is kind of a dead end, it might become better. So I think stuff like that, that's kind of around the model. It's still an AI system, but it's not just one giant DNN, can further improve its abilities. Yeah.
Yeah, and you've seen that work in like really complex and impressive ways. Like we had Noam Brown from the sort of Cicero group on, and they have planning as part of it, right? Versus it's just one very large model expect to do all the reasoning. But before I interrupted you, I'm sorry, you were actually saying like, you basically make like sometimes controversial like long-term predictions about what's going to happen. Like, there's an asymptote in sort of value of scale. And how does that impact like your decisions as CTO?
So especially as a company grows, right, it's like actually it becomes slower to change direction super dramatically. So you really want to think about like what will be too long term, or, our CEO, Ali, has this, like decision rule of like with any decision I ask about like, hey, which one am I like sort of more likely to regret like 5 years from now, not 5 months from now, but like, if I don't do this or whatever, like what's going to happen. So you try to think about where things are going to go. Of course, you do want to collect data and like sort of update your thoughts about it, test hypotheses. And that I think is something you can get from research too. Like in research, we always think when we have an idea, it's sort of a race to like figure out, is it a good idea and can I publish it? Because the research community values novelty a lot, being the first to do something, for better or worse. It's not amazing, but if you just reproduce a thing that someone else did, unfortunately, you don't get as much credit. So we do think about how can we quickly validate something. But at the same time, and even in research, I had, the same thing. You try to pick topics that will matter. Like, for example, when I was doing my PhD, I didn't do a ton with machine learning, and I knew people who did it. I helped them out. I built infrastructure, but I didn't do ML research myself. And then later, I kind of decided like, I am going to do some things, especially around this like connecting machine learning to external data sources like search engines, and I know it's going to take a while to like really learn about it and get an intuition and stuff, but I think this is going to matter long term, because I think the local parsing semantics of what the sentence means is kind of solved already, and the interesting thing will be like doing this in a bigger system.
Yeah, I have 4 degrees and no PhD. I've never contributed anything to the corpus of the world's knowledge. Elad, got to ask, does it affect how you do investing?
No, not really.
The PhD.
No,
moot point.
Really.
Nice.
Yeah. I don't know. I have a math degree as well, and I feel like that actually was a thing that forced me to think slightly differently. Or at least it forced a way of very logic. I mean, it felt like there's a groove in your brain for logic that gets carved.
Mm-hmm.
Yep.
So that probably helped, but who knows? I don't know.
You've been working in data machine learning for a long time. Like, where do you think we are in this generation of AI?
Mm-hmm. Yeah, I think we're still at the early stages of AI on unstructured data. So things like text and images and so on, really having an impact in applications. So I think, ChatGPT related features that every application is going to add will change the way we work with computing, and they'll also change data analytics to some extent, because you'll be able to use this data. And honestly, I also think that in terms of building like just basic data infrastructure and ML infrastructure, we're still pretty early. Also, it's still many different tools you have to hook together, a lot of complex integration, and you need a lot of sort of specialized people to do it. And I think over time, like I increasingly think that basically, especially because of the capabilities of these AI models, every software engineer will need to become an ML engineer and a data engineer also as they build their application. And we'll figure out ways of doing them, recipes or abstractions or whatever that are actually easy enough for everyone to do. And one analogy I like is, when I was learning programming, which was sort of like, late 90s, I got these books on, web applications, and it was very complicated. There was a book on MySQL, there was a book on Apache web server, like CGI bin, all these things you have to hook together. And now, most developers can make a web application in like one function, and even non-programmers can make something like Google Forms or Salesforce or whatever. That's sort of, basically it is a custom application. So I think we're far away from that in data and ML, but it could sort of look like that. It's harder because it depends on this sort of static data that you've got sitting around. But I do think there's, there are going to be a lot more of these applications. Yeah.
Matei, this is a great conversation. Thanks for joining us on No Priors.
Thanks a lot, Sarah and Elad.
Thanks so much.